So today we're going to start a summative assessment, and we're going to split criteria C into two parts. Part 1 we're going to do today, and part 2 we'll do the following week. You'll see within the Google Classroom that I've posted the task booklet there for you to see, and when you open that booklet, it begins with this, a reminder of what the MYP criteria C rubric looks like. And you've met this before in year 7 and year 8. In chemistry, physics and biology, it's exactly the same. And what we're trying to achieve is this highest level, 5 to 6, with these kind of things here. So you can see the different strands are laid out. Now, I also want you to think about the common formative task that we did earlier this year. And in that common formative task, we looked at this practical where we burnt food, and we looked at how we could measure the energy content of food and compare energy contents of foods using that protocol. It's worthwhile to pause the video in a moment and to go back and have a look at the scaffold sheet. The scaffold sheet is the report which talks about the whole of the practical. It's a full practical lab report, and it shows you what we need to do in terms of putting together a hypothesis, an aim, selecting the variables, etc., etc. And it also reminds us about tables and graphs and conclusions, etc. So have a look at that scaffold sheet. Have a look at the work that you produced when we did that common formative task, and importantly, look at the feedback that was offered to you at that particular moment, because that feedback is going to be useful for this particular task sheet. So pause the video here, go back and have a look at those items of work, and then continue with the video. So part 1 of this assessment, first of all, introduces you to a practical which is slightly unfamiliar, but if you think about it carefully, I'm sure you'll be able to work out what's going on. And to help you, I've put in blue here the real big takeaway messages that you need to concentrate on. So this particular practical is looking at an enzyme called lipase, and lipase acts on the substrate fat, and it breaks down the fat into the product fatty acids and glycerol. And some students were investigating this lipase enzyme, and their research question was, how does the temperature affect the breakdown of the fats in the milk using lipase? Again, it's worthwhile pausing the video here and thinking about, in that research question, can you identify what the independent variable is? And can you identify what the dependent variable is? So how does temperature affect the breakdown of the fats in milk using lipase? Now, to do this, the students used an indicator called bromomethyl blue. And this indicator will change its color depending on the pH of the solution in which it's placed in. So bromothymol blue will change color, and that indicates to you what the pH of that solution is going to be. And again, pause the video and think, well, how does pH impact this particular experiment? And look at the research question again. How does the temperature affect the breakdown of fats in milk using lipase? And what you need to think about here is, when fat is broken down, it's broken down into fatty acids and glycerol. Fatty acids, acid is acidic, low pH. So bromothymol blue is very useful for looking at the pace at which a reaction is taking place. Now, in this particular experiment, we're looking at color changes, and the color changes were observed every 2 minutes over the course of a full practical, which lasted 20 minutes. This is when the enzyme and the enzyme lipase was mixed with the milk, and the milk contains the substrate fat. And in the next slide, we're going to look at a little bit more detail about what the colors are that the indicator will change in different pHs. So we've got the research question up here. How does the temperature affect the breakdown of fats in milk using lipase? So the more fat is broken down, the more fatty acids and glycerol are going to be produced. And we can pick up that by looking at changes in the pH. So the pH for 6 is yellow, pH 7 is green, and pH 8 is blue. And down here, again, you can see this all in the task booklet. You've got the experimental setup, and what you've got are experimental pre-incubated solutions here. What we've got in this test tube is sodium carbonate and milk and indicator. So this is the substrate and the indicator. The sodium carbonate is in there to make the original solution alkaline. So that's sodium carbonate, milk, and the indicator are in one separate test tube, and in the second test tube what we've got here is the enzyme lipase, and we're pre-incubating these two in cold water. We're going to leave these in cold water to make sure that the temperature here has got an impact on both of these solutions before they're mixed. And in the same way, what we've got is the sodium carbonate and the milk and the indicator, this time in warm water, the lipase in warm water. They're kept separately in warm water, and then after a period of time, they're mixed together when all of the solutions are going to be warm. And exactly the same setup here for the hot water. And if we look at the following slide, what we can see here is the method, which is step by step. And again, this is in the task booklet. So hopefully this is straightforward. You can read this yourself. I don't want to read it out loud for you, but you need to make sure that you appreciate that the first stage is called the incubation stage, because you want the indicator and the substrate to be at the correct temperature before it's mixed with the enzyme, and you want the enzyme to also be at that correct temperature. The sodium carbonate is just simply there to make sure that at the beginning of the experiment we've got an alkaline solution. So we're going to leave these for 5 minutes, then we mix them, and as soon as we mix the enzyme and the substrate together, we're going to start the stop clock. So we've got the experimental phase here, we're mixing all of those things together, and then we're taking color readings at the start, time 0 immediately that they're mixed, and then every 2 minutes for a total of 20 minutes. It's worthwhile to look at this and consider what are the control variables, how it's controlled, and whether or not it's controlled as tightly as maybe it could be. And this slide, again, this is in the task sheet, shows you the results, the outcome of these particular experiments that the students did in those 3 temperatures. And here it gives you a little bit more information. It's saying that the cold water was actually 4 degrees, and the warm one was 21 degrees, and the hot one was actually 50 degrees. So within the booklet, you've got task 1, which says to organize, transform, and present the data from figure 1.2 in the space below in the results table. So what I want you to do is open up the booklet and to produce your own table of data which organizes this here. This is all a little bit messy. It's not very easy to follow. And what you need to do is systematically organize, transform, and present the table into a table of results, which is much more scientific. And it's worth 5 marks because there are 5 things that we're thinking that you should be able to do to make sure that your table is spot on. Then the second task in the booklet, again, it asks you to discuss the validity of the method using the outcome of the scientific investigations. And what you've got here are 4 questions within the booklet, which are going to refer to the data in the table that you've just produced in task 1. And that needs to be in the booklet, and that needs to be with you, brought to class next week when we meet actually face to face. So task 1 and task 2 of part 1 have to be completed, ideally printed off, please, and brought with you to the lesson next week. If you cannot print them off, then you need to email me before our lesson next week with that done. What we will do next week is we're going to look at part 2. So there is absolutely no need. Please do not do part 2 of criteria C. So stop at part 1, and that's the work that I'd like you to do today. Thank you.